Okay, the exponential and logarithmic review. So this is reviewing stuff we went over prior to the AZ Merit and ACT. The half-life of radium-226 is 1,602 years. If you have 325 grams of radium left after 4,520 years, how much radium was originally present? Circle originally present. We want to know what we would consider the A to be. So I don't know this initial amount. I know that we have a half-life, and the half-life occurs every 1,602 years. Now, after 4,520 years, there is 325 grams of radium-226 remaining. Some students in this particular problem got confused. Where do I put this 226? That just identifies what type of radium it is. So this is part A. Part B to solve. First, I'm going to figure out what is this amount. So I'm going to use PEMDAS to take this number raised to this exponent. So I have this number times A times this quantity that I'm looking at on the calculator right now. I'm not going to even write it down. Now I want to solve for A. Right now it's being multiplied. Opposite multiplying is dividing. So I'm going to take 325 and divide by this number that's on the calculator. 325 divided by this exact number. You can hit second, answer. So I'm going to write down the answer that I see, and I'm going to round to the nearest hundredth. And then please make sure to label it. This is grams of radium-226. Okay, number 2 is a population problem. It says the original population of this town is 2,300 people, and it's expected to triple every 5 years. How many people will be living in the town after 20 years? Original is 2,300. Expected to triple every 5 years. And for this particular problem, they're asking after 20 years if we can tell what is the expected population. So 20 divided by 5 is 4. I'm going to take 3 to the 4th power, and then take it times the original amount, which is 2,300. And the population of this town can be expected to be 186,300 people. So when I'm talking, I'm specifically talking to this row of people. How many people, by a raise of hands, feel comfortable with number 1? Hands up high. Looking at this row here. How many people feel comfortable with number 2? So I will only go over right now 1 through 8 problems where people don't feel comfortable. So if there's a problem, you're like, I don't know how to do it, and you've been here, I have no problem going over it. Okay, look at number 3 right now. Number 3. Is there anybody here that would like me to go over number 3? Hands raised. Okay, number 3. A radioactive isotope decays exponentially. The time it takes for half of the amount of decay is called the isotope's half-life. A certain isotope has a half-life of 15 hours. So half-life of 15 hours, that's how often it occurs. After 75 hours, there's this much remaining. What is the isotope's initial mass? So we want to solve for A again. This is similar to number 1. So I'm going to take 1/2 and raise it to this amount. In parentheses, 75 divided by 15. This represents this amount. And right now, A is being multiplied by this amount. To isolate the A, we're going to divide both sides by this amount. So 0.75 divided by this original amount, and the answer is 24. So what is the isotope's initial mass? 24. And it is in terms of, we've got to look up here, 24 milligrams. Would anybody like me to go over number 4? No problem with it if you'd like me to. Number 4. Would anybody like me to go over number 5? Would anybody like me to go over number 6? Okay, please flip to the back. Would anybody like me to go over number 7 or 8? 7? Okay, here we go. So the town's population is currently 6,000 people and it's expected to triple every 5 years. How many people will be living in the town after 25 years? We want to know the final amount we can predict. When the original amount is 6,000, the rate is it triples. How often? Every 5 years. Now for this particular problem, they want us to solve after 25 years. 25 divided by 5 is 5. So I'm going to take 3 to the 5th, get an answer, and then multiply it by 6,000. Correct answer is 1,458,000 people. Please take time to ask if you are unsure about any problem. Number 8. Okay, number 9, do me a favor. I want you to go to number 9. I want you to change this. I want you to cross out the x that is next to the 3 in the exponent position for the second problem. Bless you. So we're going to categorize each one of these as an example of either exponential growth, decay, or neither. As a reminder, for growth, if a problem is growth, it means the base, which in every one of these cases is in parentheses, the growth has a value that is greater than 1, not equal to 1, but greater than 1. If it is decay, that number will be less than 1, but greater than 0. And in all of these cases for growth and decay, the base will be a number, and the exponent must have a variable. It must have a variable. Okay, so I have a number, and I have a variable in the exponent, so I'm good to go. Now this number is greater than 1, so this is growth. The second example cannot be an example of growth or decay because I don't have a value that's currently in the base and I don't have a variable that's in the exponent. Neither. The third example, I have a value for the base and I have a variable in the exponent position. This value is going to be greater than 1, so it is growth. The fourth example, I have a value and I have an exponent, a variable in the exponent. So since 1/2 is less than 1 and greater than 0, it is going to be decay. Your fifth example, bless you, it has a base of a value of a number and it has a variable in the exponent position. Since 0.8 is between 0 and 1, it is decay. Can you raise your hand right now if you feel like you're understanding these? Okay, by a raise of hands, I have a 6 and it's raised to the second. So how many of you acknowledge that this is an example of growth because it's greater than 1? Hands up high. Growth. Who can tell me why it's not growth and it's not decay? Go ahead, Hervé.
Because the variable 2 doesn't have a variable. I mean, the 2 doesn't have a variable.
Yeah, the exponent position does not have a variable. This is neither. Now, when we go on to number 10, students in back, you're going to want to pay attention to number 10 because I'm adding problems to number 10 and 11 that are currently not there. So I'm going to use 10 and 11 as examples, and then I'm going to add harder problems. So right now, if you can go on to number 10. Also, Vicki, you asked me a question at the very end of the hour, and I realized afterwards I told you the wrong answer. Okay? So the Holberg family purchased a house for $175,000. The value of the home has been increasing by 4.5% per year. Circle 4.5%. Vicki asked me a great question. She says, don't I need to turn this into a decimal and whatnot? And I said, yeah. Remember, as a decimal, this is 0.045. Now, the value of the home before it increases or decreases, we consider it to be 100%. If you're at 100%, if you increase, you're above 100%. If you decrease, you're below 100%. So the rate is 100%, and we're going to increase by 4.5%. The value of this home, the original value is $175,000. And this equation allows us to tell you the value at any year. Now grab your calculator and do second plus 712. Go up here, please. Type in 175,000. 1.045 and raise it to the x value. Do not hit graph. Next, I want you to hit second table. What does this represent? If we consistently went up by exactly 4.5, okay, the appraisal amount was exactly increased by 4.5% each year, we can say the original year 0, this is what it was worth. The first year, the second year, the third year, it's continuously growing 4.5% compared to the year before. So I could say, hey, if you own this house for 10 years, what would it be worth after 10 years? Please find it. Go. After 10 years. Do you have approximately 271,770? Yes. Okay. So we're going to be using that to figure things out a little bit later. How much will the house be worth after 15 years? Well, one way to do it is this way. You have this. We're going to go down to 15. And one way to figure it out is to look and write down this number. Okay, so it's going to be 338,674. And I did that by plugging it in and going to the tables. Did you guys understand that method? The alternate method is simply to plug in 15 here. Do PEMDAS. First you're going to do the exponents and then take it times this number. So it's going to look like this. 1.045 raised to the 15. Then take it times the original amount. And there you go. Okay? Remember, the table rounds to you. Table rounds for you. So this is the exact amount. Okay, we're going to add this in to make this a little more difficult. Give me 1 second, please. This time, you are not allowed to use the table of values. Here's what I'm going to tell you, okay? The Holberg family buys this house for the same amount, $175,000. And annually, this house continues to increase in value by 4.5% every single year. I want to know how many years have they been in this house so that when they want to sell it, this is the predicted value of the home. I do not want you to use the table of values to solve this. How could you solve this? Do not use table of values. Please work with somebody next to you. I'm going to give you 1 minute, and I'll go through it with you. Go. Do not use table of values. I want you to go over the algebraic method. Are you ready? Okay, so we're going to use what I know you understand. Here's the initial amount of the house. Here's the rate that it's going to increase annually. Here's the final amount. You guys have to tell me the final amount. I forget what I had you put down. This is it right here, right? Algebraically, we want to solve for x, so let's first get rid of whatever's on the outside. Please divide by 175,000. Now we still want to solve for x, so only in this chapter have you learned how to solve for x when x is in the exponent position. What do you do now? You've only learned it in this unit. You may have said it. Logs. Log of this number. Write down the log of this number on both sides. The log of 1.045 and the base of 1.045 are going to cancel out, and we get to bring down the x. Now, how the heck do we plug this into our calculator? Well, let's just take a second. One, I need you to pay attention. Got it, guys? If I asked you to plug this in, you would say log of the back number, enter, divided by log of the base. It's the same concept. We're going to take log of the back. In this case, it just happens to be a fraction. 4,441,042 divided by 175,000. So log of the back, you should be doing the same on your calculator. Press enter, and now divide it by log of the base. So log 1.045. So what does this round to? 21 years. Does everybody see that? Okay, do me a favor. Hit second table next. Go into the second column, your L2 column. And I want you to hold down the arrow key until you come up with the same number. Do you see how you can also find it here? Please turn and talk to somebody near you so they can see both ways using the table and algebraically, both methods. Great question. Wouldn't it be faster? Right. But on tests, if you have to show your work, you have to be able to do it this way. If that's what the rubric says. Nope, that's what the district says, that you have to be able to show how to do it. I don't create the rubric for the testing.
Or miss, what if we just write down the equations and then we solve them like
Slow it down for me. So if you were worried about your method here, you can always see, okay, I want the answer to be 21, and then you can work it out to make sure you're getting 21. Does that help you?
so that would show.
So, no, what I'm saying is you still have to show this work, but then afterwards, if you want to make sure you did it right, you can check on the calculator this way. So does that make sense?
What if we get the answer and we're working on it? That's considered actual number.
No, what they want you to be able to do is solve algebraically. They want you to know this method. I'm telling you that if it's not a test or it's a quiz or something, you can show me more than one way. Does that still clarify? Okay. Going down to number 11. This time you have a condo and its original value is 90,000. And it's going to increase by 2% per year. Chris, how do I write that inside? Only Chris is going to answer. 0.002. Chris is really close. 0.002. Carlos, what is it? 0.02. Okay, 0.02. So Carlos, do you agree 0.02 is correct? Can you explain to him why it's 1.02? I didn't hear you. So 100 represents your original amount, Chris, and then you're going to increase by 2%. Okay? So here we go. What will this be worth after 17 years? Either plug it into the calculator and use the table function, or simply plug 17 in, substitute in for x, and to solve. Go ahead. When you have your answer, check with me, please, to see if we have the same. I did not put in the cents. I just kept it at this value. Oh, kept it at this value. Does anybody have questions for me about 10 or about 11? Anybody? Sure. So I chose to do just the quick way, so I took 1.02. Can you see it? And I raised it to the 17, representing 17 years, and I press enter. Take it times the original amount, which is 90,000, and press enter. Good?
Did you round that though? Did you round that?
You know, I was lazy and I just stopped here, but it will say in the directions for the test, round to the nearest dollar, or round to the nearest hundredth. Okay? Great question. Okay, ready? Take your calculator, put it down, please. Do second plus 712 on the calculator. I want to know, how long has Tommy owned this condo? If when he gets ready to sell, this is what it is worth. Approximately how many years has he owned the condo? Totally on your own. using any method. Miss Oda, did you hear me?
Yeah.
Any method you want. How many years has he owned this? Please do not share your answer with anybody else. Hands raised when you have the answer. Use hand signals. What do you think it is? Hand signals. Is this gang signs, Jasmine? I'm a little concerned. Okay, talk to somebody around you. You want to end up with an answer of 30. How do you get 30? Talk to somebody around you. Do you want me to go over it with you, Carlos? Yes? You get it? Okay, grab your calculator. Let's do it the calculator way, okay? Go up here, and we're going to, can you see it? And we're going to create the equation that represents this. What's the original amount of the condo? Okay, type in 90,000. What value represents the rate? Nice job. Raise the x value. Now don't hit graph, hit second table. And then you're going to go up and down that y column until you find approximately, was it 163? 30 years done. Okay, can I do it quick? You watch. Okay, ready? So watch real quick. Okay, can you see?
I did it. When you divide it by 90,000, you put the log. Log 1.02 equals.
Now I'm going to be a little bit lazy here. Do you guys know you'd write that thing right here, right? Okay, this cancels. And I bring down the x. Now when we plug this in, it's going to be log of this back number. So let's try it together. Ready? Log of, and you're going to read it to me, it's 163,022, right? Divided by 90,000. No. Then end parenthesis and enter. Now divided by the log 1.02. See how that rounds up to 30? Are you guys comfortable with that? Yes or no? Yes, Em? Em, do you have a question? You sure? Okay. Bambi, do you understand that? No, you don't? It's okay to say no. I can help you again.
I multiply instead of divided.
Do you need some help with that, Pablo? Yeah. I can help you with it when we're done with this. I have no problem going over that with you again, okay? All right. Please find 14. We are doing 12 and 13 at the beginning of class on Monday. So please find 14. I would like one person between you and the person sitting next to you, or you and two people, one person to read this out loud. When you're done, please do second plus 712 on the calculator. Ready, go. Okay, 5. Here we go. 4, 3, 2, and 1. I'm going to ask that whether you're sitting up front or in back, you stop and you pay attention. We have lots of keys to do here. If you hit stat and you hit enter and it says L1, L2, or sorry, L2, L3, can you use this calculator? No, what does it have to say? So I'm going to try my next one here. Hit stat, And enter. This one doesn't work as well. And we'll try this last one.
So Miss, it doesn't work if it doesn't say that, or what?
Right. Okay, do you see how I plugged in these numbers for L1 and L2? I'd like you to do the same. I would like you to hit stat, I'm talking. Hit stat edit. In L1, plug in all of the times. In L2, plug in all of the temperatures, and then stop. We're going to do A through D together. Bless you. A specifically says use a graphing calculator to find the exponential model. Now, before you do that, B says how do you know if this is a good model? So for us to do A and B together, I'd like everybody to turn the diagnostics on. Now, it's been months since we've done this. Please hit second, go down to catalog, hold down the arrow key, until you find diagnostics on. Once you find it, press enter twice. Then hit stat, calculate, and it already says please find the exponential regression for part A. So go down till you see EXP and reg for regression. And you're going to have to enter twice. For me, I have to hit a few more because it's just a different program. But this is the answer that you should get. How many of you have this? Hands up high. We are focused on the R value. This will be the initial value, and this represents the rate of change. Okay? Initial value. So let's just do some analyzing first of all. Remember that this is going to be an average of the points. This is going to be an average of the points, taking the points, and they're going to try to best place them on an exponential curve. So if this was true, it says the initial temperature of the coffee is approximately 171. Now, your B value, it's less than 1. What can you tell me about the temperature if the B value is less than 1? It's decreasing over time. Did you ever hear that? Now, what if that coffee was like on the stove and instead it said 1.03? What would be happening? What would be happening to the temperature of the coffee? It'd be increasing over time. So we know it's going down. This R value, if it's really close to +1 or -1, it tells us that we have a good fit for our points. So it tells us to round to the nearest hundredth here and to create an equation. So we have y equals, I'm looking at the same screen you have, 171.46 times 0.9, I have to round, 0.99 raised to the x value. Getting that from here, and I'm rounding to the nearest hundredth like the directions say. Now, how do you know whether it's a good fit? Is it a good fit, yes or no? Yes. Now, according to things I've read, they say that if you are 0.8 or above, either positive or negative, that means you're getting close to +1 or -1, we consider it a good fit. I prefer to be in the upper, we'll call it 90. So very close to -1 or very close to +1. In words, you need to explain why it's a good fit, and it's based on that R value. I'm going to give you 15 seconds to do that in words on paper right now. How do we know it's a good fit? Because what value is equal to? negative 0.98, which is really close to negative 1. Part C says we're going to use the exact equation from the exponential regression model, and we want to determine when is the temperature equal to 106 degrees. Notice it says degrees, and if I look up above, degrees is a y term, so I'm given degrees. So come back to part C and write y equals 106. Okay, now take your calculator, please. I want to make sure I didn't mess up. Okay, take your calculator. You need to be on this screen, so hopefully you're still here and you didn't mess up like I did. You need to be on this screen. Do you guys have this out right now? Yes, no? Okay, you ready? We're going to get this exact amount. Well, it's going to be slightly rounded at the end, but pretty close. Hit y equals, please. Please be over the top of y sub 1. Please hit vars. Go down to statistics. We learned this, but it was last semester. Press enter. Go to EQ. Press enter, and the exact equation will be implanted into your y sub 1. Okay? Press graph. Now here's the deal. We need to change the dimensions. So can you hit Windows, please? Hit Windows. I'm sorry, it's still thinking. Do you agree that the x goes from 0 to 50? Yes or no? Yes. So let's change this from 0 to 50. Now the range. The lowest number in the range is approximately 100. The highest number in the range is 180. We can't type in 180 and then 100. It's first the smallest number and then the largest. Once you've done that, please hit graph. By a raise of hands, how many of you have something similar to on your calculator? Hands up high. Okay. Kind of. Do you have your range wrong?
I don't know how you got the x-split. I mean the r-squared and r.
Okay, so I'll help you with that later on. Okay, gotcha. Thank you, Chris. Okay, we're going to go here. So, as a review from last semester, it tells us what the y value is. When they give you the y value, it's a little bit more work. Come up and go to y sub 2 and type in the y value they give us. Now hit graph. Dwayne, can you share with us how am I going to find the answer?
Second trace, intersect.
Thank you, Dwayne. Okay, go ahead, guys. Please do first curve, second curve, and guess. So how many minutes did it take until the temperature of the coffee was approximately 106 degrees? Approximately 41 minutes. Do you guys have that? Okay, here we go. 41 minutes approximately. Going down to part D. Based on the new equation, and they use the graphing calculator, predict when the temperature of the coffee is 1 hour. Well, hours are in terms of x values, but I cannot write x equals 1. Why can't I say 1? Because it's in terms of minutes. So 1 hour is 60. Go back up here and hit the button that says Windows. Before I can use the calculator to do this for me, I need to extend the value. So let's go to 60. Because I want to know what is the x value at 60, so I need to have it in the range. Now hit graph. And it's pretty easy when they give you an x value to find. So we're going to go second trace. Give it just a second. Second trace value, type in 60 for 60 minutes. And what is approximately the temperature after 1 hour? It would be approximately 84 degrees. Okay, with your partner, I'd like you to look at 16, 17, and 18. You will talk to people around you as I do them. If you are really confused, you can just watch what I'm doing, and you can ask questions when I'm done. Finding the inverse, we're going to switch the x and y. Okay, to eliminate the log base 3, I'm going to make this into an exponent and this into a base. 3 and log base 3 cancel, and this comes down. And now I add 4 to the opposite side. And I have 3 raised to the x plus 4 equals y. Now this is the inverse. We're going to denote it with a negative 1. Same thing, let's switch the x and y. Now we want to isolate the y, so I'm going to start by getting rid of the 7. I add it to the opposite side. Now we need to eliminate the e so that the y plus 3 comes down. Now a couple ways we can do that. We can write log base e. But as a reminder, log base e is the same as the ln. So these cancel, and I bring down y plus 3 is equal to log base e of x plus 7. Come back over here, and now I want to subtract 3 to the opposite side. So log base 3 of x plus 7, subtract 3. Or you may see it as the ln of x plus 7, subtract 3. Equivalent forms. Okay, your last one for number 18. You're going to rewrite this log in exponential form. This is your base, it remains as your base. This is your exponent, and this is your answer. Now solving for x, we want to eliminate this so the x plus 3 comes down. So I'm going to do the log of 2 to both sides. And now I want to solve for the log base 2 of 64. Some of you can do that in your head. Others will plug it into the calculator. Remember, you're going to hit log of the back number divided by the log of the base to get an answer of 6. And your last step is to subtract 3 to the opposite side to get a final answer of x equals 3.